Alrighty, guys, we are going to wrap up solving absolute values today. Same idea as what we did yesterday, just a little extra to it. So what you're going to notice with your problems today is that the bars are not going to be alone. They're going to have a little something extra on the side, either adding or subtracting a value, perhaps multiplied by a different value. So our job today is to first isolate those absolute value bars. Again, the absolute value of a number is talking about the distance away from zero. So in order to be able to say we can travel to the left or to the right, we first have to have those bars all by themselves. So our first step on this problem would be to add 5 to both sides. That'll give me the absolute value of 10 minus 2x equals 18. And now that my bars are alone, it becomes a problem just like yesterday. So I'm going to split it into two problems. 10 minus 2x equals 18, like we're traveling to the right, and 10 minus 2x equals negative 18, like we're traveling to the left. Then we go ahead and solve it by subtracting 10 from both sides. That's negative 2x equals 8. Divide by negative 2, that gives me x equals negative 4. And on the other side, same thing, subtract the 10 from both sides. That gives us negative 28. Divide by negative 2, and we also get x equals, looks like a 14 to me. Same idea, just taking that one extra step at the beginning before you separate it into two separate problems with the positive 18, negative 18. Those bars have to be alone first. Alrighty, go ahead and pause the video and give this one a try on your own. I'm going to first get rid of divided by 6. So to do that, I'm going to multiply both sides by 6. That gives me the absolute value of 9x minus 4 equals 18. Now that the bars are isolated, I can set it into two separate problems. 9x minus 4 equals 18, like traveling to the right, and 9x minus 4 equals negative 18, like traveling to the left, and then solve each of them. I'm going to add 4 to both sides, so 9x equals 22. Divide it by 9. I don't think that can be reduced, so I'm going to say x equals 22 over 9. Or, on this other one, add 4 to both sides. 9x equals negative 14. Divide by 9. We can say x also equals negative 14 over 9. Alrighty, so same idea on this one, isolating the bars first. Notice that we have it being multiplied by a value as well as added to a value. So when I look at this problem, I kind of think of this chunk in the bars as x. So it's kind of like negative 3x plus 10 equals 1. And looking at it like that, I feel like kind of helps you decide what number should you get rid of first. Remember, we go order of operations backwards, or SADMAP. So when I look at this then, I'm going to go ahead and get rid of that 10 first, so minus 10. I'm going to just rewrite this left-hand side, and that'll equal a negative 9. Now notice at this point it equals a negative number, but I'm not going to make any assumptions right now as to whether or not it has an answer, because I still have to get those bars alone. So don't just jump at it and say no solution. We still got to get those bars alone before we can make that kind of judgment call. So to get rid of this negative 3, do not distribute. Go ahead and divide both sides by negative 3. That'll then give us the absolute value of negative 4 minus 7a equals positive 3. Now that the bars are alone, I can evaluate it and ask myself whether or not it's going to have an answer. Because it said equal to a positive number, it looks good. And because the bars are now alone, I can separate it into two problems. So I'm going to say negative 4 minus 7a equals a positive 3. And negative 4 minus 7a equals a negative 3, and finish solving it. So I'll add 4. Negative 7a equals 7. Divide by negative 7. That tells me a equals negative 1. And on this side, add 4. Negative 7a equals 1. Divide by negative 7. I'm going to say a also equals negative 1/7. So our two answers are there. Give you one to try, and then we'll be all done. Right, you can go ahead and pause the video and give this one a try on your own. I'll go ahead and start. Negative 4 and also the minus 2. We're going to SADMAP, so I'm going to get rid of the 2 first. So negative 4 times the absolute value of 6 plus 6n equals 96. Again, I'm not distributing this in. I'm going to get rid of it by dividing. So the absolute value of 6 plus 6n equals a negative 24, I believe. Now notice my bars are alone, so at this point I could separate it into two separate equations, but notice even more so is that fella right there. The distance from 0, the absolute value of something, cannot equal a negative number. So if you notice this immediately, once your bars are alone, it can only be established once the bars are alone. If the bars equal a negative number, you can immediately say no solution. Hope that helps, and if you have any questions, email me or I will see you in Google Hangouts. See you later and good luck.